Surface water quality of small rivers in Ukrainian regions of right bank Polissia. Deteriorating ecological conditions of river systems in Ukraine as a result of irrational use of water resources and technogenic impact are an ever-present problem, a problem for present and future generations. The main sources of pollution of river basins are industrial and municipal waste waters, agricultural runoff, surface water runoff, and atmospheric precipitation. Monitoring environmental conditions of surface waters is one of the key tasks of the state's environmental activities, calling for joint efforts and resources of neighboring states, aiming to preserve, rationalize use of surface waters as well as facilitate mutual integration of national and international laws, standards, and allow for continuous international environmental cooperation. Purpose of this paper is to give assessment of the surface water quality of small rivers of the Ukrainian regions of right bank Polissia. Objects of study are the rivers Vuzhivka, Tyria, Tsur, Stokhid, Styr, Lipa, Prudnik, Serna, Chornoguzka, Horень, Putylivka, Sluch, Udort, Ush, Noreny. The conditions of said rivers were studied by us during a 20-year period from 1999 to 2019. Resulting materials include statistical and cartographic data on the ecological conditions, use of land and water resources in the small rivers of the region. The evaluation of ecological conditions of water quality in the rivers belonging to Ukrainian regions of right bank Polissia was carried out according to methodology of ecological assessment of surface water quality by relevant categories that allows to compare water quality in individual bodies of water and in bodies of water situated in different regions on the basis of uniform ecological criteria. It includes 3 blocks of indicators: block of salt composition, I1, block of tropho-saprobiological, ecological-sanitary indicators, I2, block of indicators for specific toxic substances, I3. Block of indicators for salt composition, I1, includes chlorides, sulfates, and mineralization value. Block of trophic and saprobiotic ecological-sanitary indicators, I2, includes suspended matter, nitrates, ammonium, phosphates, dissolved oxygen, pH, chemical oxygen composition, and biochemical oxygen composition for a period of 5 days. Block of indicators for specific toxic substances, I3, which has 1 to 8 components which include general iron, copper, zinc, manganese, total chromium, phenols, petroleum products, and active synthetic surface substances. The average values for the 3 block water quality indexes are determined by calculating the average number of categories for all indicators of a specific block. The 3 worst values for the block are determined by relatively worst indicators among all indicators of said block. An integral ecological index, i.e., is calculated using values of blocking indexes to determine the class and water quality category. The procedure for determining the categories of water quality according to the ecological classification for each hydrochemical indicator by average values allowed the absolute quantitative values to be converted into unified, integrated indicators of water quality, indexes, categories, subcategories, classes, which reflects the essence of the process. The anthropogenic impact was reflected by the changes of set indexes, as implementing quality water management, implementation of environmental protection, and restoration of natural environment are key components of sound state policy of water protection and management. Calculated values of the integral ecological index, i.e., was compared against existing environmental classification that has 5 classes of water quality and is widely accepted by other European countries. These classes have certain characteristics and also have corresponding color on the chart that is used to classify the water and allows to clearly illustrate how good or how bad is the water quality in specific body of water. Evaluating the water quality by the indexes of salt composition, the average values and the worst values of the index were characterized as excellent and very clean for average values, with index being situated between 1 and 1.3, and then worst values were between 1 1.7 and 2.0, indicating that the quality of water was still very good and clean. On the other hand, during our study we observed that the river Ubord and the Noring had deteriorating water quality, and their indexes were between 1.7 and 3.0 and 2.0 and 2.7 respectively, which indicates that the water quality was varying from very good and clean to good and fairly clean. Overall, the quality of water in the rivers that we studied was according to the tropho-saprobiological criteria corresponding to class 3 of the water quality, meaning that it was satisfactory but polluted. The main reason for the current state of the rivers in the region is an excessive content of nitrogen and phosphorus compounds in the water that can be explained by intensive eutrophication. Obtained index of specific toxic substances, I3, indicates that there is considerable pollution by the said substances of the small rivers that were studied by us. Overall, the value of I3 for the Pripyat river ranges between 4.4 and 5.2, by its worst values being satisfactory, slightly polluted to mediocre and moderately polluted waters, and on average being between 3.1 and 3.4, that is good, fairly clean, to satisfactory and slightly polluted water. Unfortunately, limited data from the field experiments allowed us to determine only an approximate grade of the water quality by their degree of pollution by toxic substances. Nevertheless, obtained data allowed us to see the clear trend for reduction of iron and chromium contact in the water, but nickel content, on the other hand, has increased substantially in the water, and the water therefore has deteriorated from category 2 and 4 by their average and worst indicator to category 5 by both indicators in terms of their nickel contact. Nevertheless, there has been an observable increase in water quality in terms of this block of indexes from category 5 and 4 by average and worst values to category 3 overall, that being class 2 of water quality, indicating that the water is good and is clean. By combining data from the three blocks of indexes, we can calculate an integrated ecological index that will give an approximate condition of the water overall. Using this index, we can give quantifiable information about the quality of water in the following rivers by their average and worst values. Pripyat has an average value of 3.0 and worst value of 3.7, Tyrya 3.2, 3.8, Tsir 3.3, 3.9, Stokhid 2.8, 3.6, Shtyr 3.3, 3.8. Therefore, said rivers are between categories 3 and 4, being fairly clean and slightly polluted. Overall, rivers studied by us range in their quality of water from good and clean to satisfactory and polluted. Best water quality was observed in river Chernohuska with integrated index between 2.5 and 2.6, Serna with 2.3 and 2.6, and the worst quality was in the river Buzhivka 3.1 and 3.9 and Ser 3.1 and 3.9, as well as Uj with its 3.7 and 3.9. Despite the bad quality, water still has improved substantially by their worst values, as they have moved from the class 3, satisfactory and polluted, to class 2, good and clean, as compared to the last period of study. The following can be done to improve the quality of water: reconstruction of existing and construction of new water treatment plants, elimination of untreated discharges, and stricter enforcement of existing water protection legislation. In conclusion, results of our observation indicate satisfactory condition of the small rivers in the Ukrainian regions of Red Bank Polissia. Regular assessment of water quality is essential in construction of effective and sound regulations and legislation regarding water protection and water usage, as all this indicates prospects for future studies of surface water quality in the Ukrainian regions of Red Bank Polissia. Thank you for your attention.